Science is wrong, and I'm going to tell you why. No, I'm not against science, and no, I'm not coming from a religious point of view. I could also tell you why I think religion is wrong, but that's for a different video. But as for science, once you understand the base of science and what it means to humans, and then you understand the reality that humans live, then you can understand why science itself is wrong, and many scientists already understand this. I don't get paid to do sciencey stuff.
I didn't go to a fancy science college to get a fancy piece of paper, to get the approval of fancy people telling me that they fancy my scientific opinion because of the piece of paper that proves that I am also fancy.
I've just done a lot of research over the course of my life.
Through front and back end channels.
I've researched many scientific studies carried out by the United States, and some carried out by other nations, such as Russia and other nations in the UK, along with China. I've also studied many of the ancient texts from all around the world. I've done this since I was a kid, and for the past 20 years at least, with the most important contribution to the conclusion that I've come to in my own mind is the thought experiments that I put myself through. One of my favorite thought experiments to put myself through is to try to become completely still and to see what that would look like. Many times I've tried this thought experiment, and a lot of times it ends up different, but most of the time it's very similar in my mind. When I become completely still, that means that I am no longer moving in any sense. That doesn't just mean that I've stopped moving on planet Earth. That means that the motion of the Earth and my motion has been separated. I have pumped the brakes, so to speak. And now the Earth is no longer pulling me with it, and I am no longer orbiting the sun. Therefore, I have escaped the gravity of the sun, and the sun is now flying far away from me into deep space, obviously carrying the Earth along with it. We can go further into this thought experiment in the future. If you guys want to, then let me know in the comments if you guys want to hear what I think about that. But to stay on topic, the moment the thought experiment removes me from Earth, it tells me that a critical variable is overlooked in 100% of scientific experiments, including my own. The scientific method has pretty much 7 steps. You need to question, you need to research, hypothesize, experiment, collect data, and analyze the data, come to a conclusion, and communicate. For this topic, we need only look at the step of experimentation. In order to make a scientific experiment, you first need an independent variable. This is the variable that you will change as the experimenter. And then you need a dependent variable. This is the variable that is measured to see how it changes in response to the independent variable. And then you need a control group. A control group is a group of subjects that does not receive the independent variable, so it does not change. First, let's take an example of what could be considered a non-scientific experiment. In conjunction with our point here, imagine conducting an experiment. On a raft in the ocean, you are at sea level. Then imagine conducting that same experiment at the bottom of the ocean. And then imagine conducting that same experiment at the top of Mount Everest. Now, depending on the experiment, these changes in location, atmospheric pressure, temperature, humidity, and so many other factors included with changing locations in such a drastic way would cause this experiment to be invalid unless the experiment was to decide the differences in the different locations, meaning that the locations were one of the variables in any other sense of any other type of experiment. The results have a high risk of being altered due to the change in position on Earth. The conventional view on how to fix this is to just stay in one place, and that seems to solve all of our problems when it comes to the scientific process. But these only solve some of the problems, to be more accurate, and the problems that it solves are only relative to our perspective. In reality, you're supposed to be able to conduct a repeatable experiment that proves that your hypothesis is, in fact, correct. The problem with coming to this verdict is you can most likely never conduct the same experiment, or even a similar experiment in the exact same way, ever. And that goes beyond the intricacies of the shaky human hand or the imperfections of our engineering and design to accomplish such experiments in a more artificially complete way, or in other words, in a more cookie-cutter fashion, to ensure that your experiment is always the same every time, except for the changing variables, so that you always are able to prove without a doubt, in the name of science, that your theory is either correct or incorrect. The reason why you cannot ever perform an experiment the same way twice with our current technology is because, in order to conduct an experiment the exact same way more than once, we would have to have the ability to travel in excess of the speed of light. You would need to travel in the correct direction, the exact speed at which the universe is expanding. This means you'll have to leave Earth unless you can figure out a way to move Earth and the sun that fast. One could make a very decent argument to say that. Well, if you're in a room on Earth enclosed from the environment that is unchanging to the perception of humans, then the scientific method is solid because nothing really changed in our perspective. So it proves in our perspective that that's the truth, or that the theory has been debunked. One could also make a solid argument to state that there could be processes in the universe that take place that affect everything without humans being able to detect them, because it's outside of our perception, not only light, but even physical matter itself. I say this because the alteration in your position as you are moving with the orbit around the sun, and the sun's orbit around the center of the galaxy, and the galaxy's motion through the universe ultimately changes every variable in your experiment, including the control group. Because the control group is changing position, not to mention the entire experiment itself. This may not seem important, but what seems is only dependent on one's perception, and one's perception is dictated by their position in their environmental conditioning. It's what renders their ability to render. So the unseen truths of the universe that affect or do not affect our experiments exist, whether or not we choose to acknowledge them. In science, it's becoming more open to agree that the universe is made up of many waves. Everything is practically a wave, so imagine. If the universe is a wave goes up and down the high point, and the low point and how far those two are apart tells you its frequency and how fast it vibrates. In translation, how the atoms are placed will tell you what the structure looks like. So imagine you ride a wave, you'll go up and down over and over. So that means that when you exist, you move through space, or the universe on its wave. So, in a sense, you exist in an up and down perpetuality. This truth of the wave in the universe exists throughout everything. Even if you don't experience it with your eyes, or even understand that it is happening around you. The most recognizable way in which the universe reveals itself to us in this way is through water. Water is perhaps, along with other liquids, one of the easiest ways for the universe to translate itself to us. And this wavy motion exists even with our own solar system. Our entire solar system oscillates up and down the galactic plane in a cycle of around 66 million years, reaching the maximum of 75 parsecs in height and depth. If you were to look at the Milky Way from the side and see a flat disk and trace the path of the sun, it would go up and down like a wave. Now, these numbers are incredibly large, unfathomable for most people to even understand or visualize. It happened on much smaller scales too, but the fact that the large scale and the small scale is happening clearly for us to observe, we can just use the macrocosmic observation of the sun oscillating up and down the galactic plane. Right now, it's on a downward motion towards the galactic plane. Every split second, every fraction of a second that passes, you are constantly closer to the galactic plane. At this point, you are going down the wave. You are constantly in a different position. It's unknown to humans how our position in the galaxy in relation to the galactic plane affects anything in our lives. The only thing that we can come to imagine that the most effect would have on us would be the gravity of the more densely populated regions of the galaxy being towards the galactic plane. So the gravity may have an effect on our experiments. But there are also many other factors like light. There is more light near the galactic plane. Most forms of light are absorbed by the matter or reflected by the matter that it comes into contact with, but many forms of light can actually penetrate matter. So as you get closer to the galactic plane, more of this penetrating light is going to be able to penetrate your controlled experiment, and if you are able to shield that out of the way, that's just one variable. As you get closer to the galactic plane and also closer to the center of the galaxy itself becomes more dense with particulate matter, basically freeze-dried bacteria and other particles floating through space. These are microscopic and subatomic particles that we only know exist because of mathematics, and it'll be another 1,000 years before we can develop instruments to actually observe them with our own senses. We may never be able to observe them with our eyes. And many of these particles also pass through matter. Using things like a Faraday cage can oftentimes eliminate most of this, but there are also energies in the universe that penetrate matter along with Faraday cages and transcend even time. Some of these don't even respect our understanding of physics. Quantum physicists may agree with this. Like I said, though, I'm not an accredited physicist or scientist of any kind, but I do know that quantum physicists know that things get really weird on the subatomic plane, and they have to imagine that if that's the case, that we don't even know anything, because If the universe is basically a cyclical construct, then as things get larger, physics should also fall apart, just like as they do when they get smaller. That is just to say, maybe we haven't seen the bigger picture yet. So imagine these energies ever changing as you move through the universe. That means that ever changing amounts of energies will be moving through your experiment every second that you conduct your experiment, which means that you can never really conduct that same experiment unless you travel in the right direction and speed to compensate for the sun's oscillation up and down the galactic plane and its rotation around the galactic core. Take into account the galaxy's motion through the universe, and then you have to take into account the expansion of the universe itself. Because as the universe expands, it stretches the waves. So in a sense, the universe gets deeper and deeper as a frequency because the high point of the wave and the low point of the wave are expanding, being stretched out further and further. So you need to also account for this change in the universe's position. That's why you need to be able to travel as fast as the speed of the universe is expanding, and exactly that speed. But before all of this, you need to chart a course so that you don't collide with something while you are stationary. All these other moving objects can collide with you, so you need a chart of course and then account for that and the change in speed. So technically you need to be able to travel faster than the expansion of the universe, and you need to be able to adjust the speed up and down exactly in relation to your course direction changes. And you have to ensure that you are always moving in the right direction while doing this. Maybe the universe truly is cyclical, as it seems, and maybe we can conduct the same experiment more than once. Maybe it just takes the Milky Way a few trillion years to rotate around whatever it is the center of the universe is. And then in that moment, the Milky Way will be in the same position. It was for you to perform that experiment. And you can hope that the sun is in its same oscillating position, that it was the last hundreds of trillion years ago. But likely you're going to have to wait hundreds of trillions of these rotations just so that the oscillation and the rotation of the sun, the galaxy position next to Andromeda and next to any other galaxies around us and everything else is exactly the same as it used to be. But what are the real odds of that happening in the life of any civilization? Let alone the war like humans. Another theoretical way you could achieve this stillness is to create this stillness artificially, but without leaving Earth. You would need to create a force that surrounds you and your experiment, or at least your experiment. This force must then separate you from the Earth's gravity, from the motion of the Earth, and from any influences that the Earth or the sun or the universe itself can have on you. This includes time. But once you've achieved this, it doesn't really matter, I guess, any experiment that you have to conduct, because if you can separate yourself from the effects of time, then you have achieved immortality, which is way more valuable than any experiment you were trying to do anyway.